Hey, it's Casey. Boom. First, we're going to talk about my personal favorite from one of the first things that we learned is IVT, because personally it is pretty commonsensical and it's easy to do. So here we go. Alright, IVT stands for Intermediate Value Theorem, but you will never have to say that on the calculus test, the AP test. You'll just have to say IVT. And usually you'll use the little 3-dot thing that means therefore, blah blah blah, by IVT. Bada bing, bada boom. You're good. IVT has 3 rules that when you're solving a problem, they have to go by these rules, and therefore it goes by IVT. So if it all works out, then you're good. So rule number 1 is a duh. F of x must be continuous. So on a graph, blah, blah, there's no holes. Actually, so on a graph, say you got this number, closed interval, no sharp points or anything, no tangent lines, or not tangent lines, no vertical line in this. So this little doohickey, say that this is K and C. IVT says that, say you're driving 10 miles per hour, and then at some other time you're driving at 60 miles per hour. Somewhere in between those two you had to be going 30 miles per hour, right? That's what IVT says. So speed is continuous, so f of x would be continuous. So rule number 2 says that f of a cannot equal f of b. So your starting point can't equal your ending point, because then there's no way to know if you meet in the middle. So if you start out going 20 miles per hour, you end going 20 miles per hour, who's to say you ever went 35 miles per hour in between the two? Because there's no way to know by IVT. So then rule number 3 says that f of a is greater than k is greater than f of b. Or this could be b and this could be a, but k always has to be in between the two. Duh. So 10 is less than 25 is less than 60. So IVT. Alrighty, so I have a practice problem up here. Show that x cubed minus 3x plus 1 equals 0 has a root at the interval 0, 1. Now a root is just where the equation equals 0, and bada bing, bada boom, it's already there. So now we just need to determine if this function can be solved with IVT. So first off, we need to find out if it's continuous. So 1. And I'm just going to show this on the calculator so it's easier for you to see. That's what it looks like. So now, yes. So we're just looking at the interval from 0 to 1, so from right about there to 1. So this little bitty chunk. Oh, that f of x is continuous. Good. Now, plug in 0. So 0 cubed minus 3 times 0 plus 1. That will equal 1. Then we're going to plug in 1 cubed minus 3 times 1 plus 1, and that equals negative 1. So, 1 and negative 1 do not equal each other. So, we know this part applies. F of 1 does not equal f of negative 1. Now we just need to find out if the term is in between. So we're trying to find where it equals 0. So negative 1 is less than 0, is less than 1. So f of, let's say that negative 1 is f of a, and one is f of b, so f of a. So f of a is less than k, because 0 equals k, right? Because that's what we're looking at. It's less than f of b. Boom! Therefore, IVT holds. Woo! Next problemo. I've got f of x equals 2x cubed plus 4x minus 5. The interval is negative 2, 1, and our k is 4. So we're going to see if IVT holds. So, first step, gotta find out if it's continuous. It is! Woo! F of x is continuous. You bet it is. 2. F of a equals, so we're gonna do this. A is negative 2, so 2 times negative 2 cubed plus 4 times negative 2 minus 5 equals negative 29. So f of a equals negative 29. F of b equals, so we're going to go to 1 cubed plus 4 times 1 minus 5 equals 1. Uh-oh! If you haven't noticed the problem yet. So f of a does not equal f of b. So that's good. But you see our interval? Negative 29 is less than 1 is less than 4. So that would be f of a is less than f of b is less than k. So therefore, IVT does not hold because it didn't follow all 3 steps. It has to follow all 3 steps for IVT to work. So since it didn't follow the last one, it doesn't work. So I have an example of one where it does work and one where it doesn't. So now hopefully whenever you're able to do it on your own, you can see the difference. And next up, I'm going to be doing implicit differentiation, so stay tuned.
Tell me why this works so well. Tell me why I write so big. Implicit differentiation! Boo!
This one's all about derivatives. So we went from IVT, which is no derivatives really, onto something that is derivatives. This one's fun in the sense that you get to start using a little bit of this notion. What does this mean, you're thinking? Well, I will tell you. So, before and I didn't make this a part of the video, but before we were taking derivatives like, let's say we have 2x cubed plus 3x squared plus x minus 1. So with the shortcut, you just multiply the exponent by the coefficient and then subtract 1 from the exponent. So for here, this will be 6x squared plus 6x plus 1. And then since there is no exponent or whatever, the constant will go away. So this would be the derivative of that. So when doing it like that, taking the derivative of something with respect to x, you would be writing dx after taking the derivative. But since dx is really just 1, that cancels out, and that's why we never wrote it. But whenever you're taking the derivative of something that's with respect to another letter, I don't know the word for it, but then you'd have to write dy dx, or with respect to w is dx dw, blah blah blah, blah, that kind of thing. It could be for any letter. So let's say we have 3y squared minus 5x plus 500. Why not? Whenever you're taking the derivative, we're going to do this in respect to x. So this will be 6y dy dx minus 5. And then that cancels because it's a constant. And then we're going to have to put it find out what dy dx equals. So we're gonna add the 5 over, so we have 6y dy dx equals 5. Then divide by 6y. So dy dx 5 over 6y. Simple enough, right? Okay, let's do another example. So let's just say we have x to the 6th plus y to the 3rd minus 3x plus 12 equals 0. So finding the derivative with respect to x. 6x to the 5th plus 3y squared dy dx minus 3, and that's a constant, so it goes away. Now we have to find what dy dx equals. Dy dx, what a guy. So this will be 3y squared dy dx equals 3 minus 6x to the 5th. Then we just divide by 3y squared. And then on this, before I start making it equal and whatnot, we can take 3 out of all of this. So the dy dx equals, take a 3 out, 1 minus 2x to the 5th y squared. So I feel like that's not too bad. Implicit differentiation. So that's all that I have for today. Thank you for watching. I really hope that this helped. I'm probably not the best at explaining things, but here I am, and you have a swell day. Good job.